All right, so I believe I'm recording. Can you see that, Jeff, and confirm for me I'm recording?
Yes, looks good.
All right, okay, so welcome everybody. This is our week 8 of the first session of our training. And a question was asked, and I'll remind you that you're all registered for sessions 1 and sessions 2, so have a good break. We'll see you guys back. While you guys are on break, I'll start looking to see, who's been doing some of the work and is working towards that CCR credit and try to get you some status information. And today we've got Mahidar speaking about GPU profiling and monitoring using some different tools, Nsight and communications. So with that, I'll stop sharing and turn it over to you, Mahidar.
Thanks, Mary. So let me see if I can get my PowerPoint up. Okay.
While he's setting up, are there any questions anybody has? Okay.
So I hope I have the right share now.
Yeah,
it looks good.
Okay. All right, so let's get started. So today I'm going to talk about GPU profiling on Expanse. And just a quick outline of what we'll go over. So I'll start with nvprof, which is a command line based tool, and but it has a lot of nice features, and you can do a lot just with the command line options. So we'll take a look at some of the options that are available. We'll take the standard CUDA toolkit examples and just illustrate how the profiling will work. Just look at how we can export one of these profiles and then import it in a different tool. And also look at an OpenACC example, which is also feasible to be profiled using nvprof. So that's kind of a simple approach. But then NVIDIA has the Nsight based options for profiling, which are way more detailed. So today we'll mainly look at the Nsight Systems, and the reason for that is actually the compute part of it is actually disabled on Expanse right now for security reasons. And this is actually true of a lot of the profilers. I'm sure Bob talked about it with uprof as well, that you have to set one of those paranoid variables to not paranoid. So something similar is there with the GPUs, and right now there is a security bulletin which essentially makes us turn that off. So it's probably going to get turned on in the future, and we probably allow it as a feature. But for now, we can look at Nsight Systems, which works for a bulk of the things I want to show today. So that's a nice, neat little thing you can try out yourself. Nsight Systems basically has both command line and GUI options, and we'll look at how to generate that and then move that off to your local machine and see how you can view that and so on. Again, we'll look at some of the standard examples like matrix multiplication and linear solvers to illustrate the use. So to start off with the nvprof, so this is a command line tool that basically profiles CUDA related activities on both CPU and GPU. And you can display the results on the console, or you can save them and then view them using either nvprof again or the visual profiler that NVIDIA has. One thing I want to note is both of these nvprof and nv visual profiler are going to get merged into, their capabilities will become feasible in Nsight in the future. So you would have the same CLI options on the Nsight side, and they will probably deprecate these. But right now, these are the easiest ways to get things going. So what are the kinds of things you can do? So there are a lot of options depending on which piece you want to profile, or you want to do both. You can do both. So there are CUDA options, and then there are all kinds of events and metrics, and I'll give you an example of the kinds of things you can look at, and kernels, and how the memory is being used, and the source level analysis, and a dependency analysis. So there's all these options. There's also like CPU options, which relate to like how deep you want to look at your code on the CPU side. You can basically modify the scope of what you want to look at, and also look at OpenACC and OpenMP. And it's a nice thing to have both of these CUDA CPU and CUDA pieces integrated into the same tool, because I can look at both the API calls from the CPU side and then what happens on the CUDA side. So you can get timelines for all these. Then there are some options that are kind of related to just how the I/O looks, and summary and export, and like writing out the log files that we can look at. Now if you go look at that link on the nvprof that I have, there's a lot of options and there's no way we can get through all of them in such a short period. So what I'm going to do is try to just give you a flavor of what to do, but you can definitely go look at it and play around a little. One thing I want to say is, even with nvprof, not everything is open right now for the same permissions reason, but you can do a lot. So what I'll do is show you some slides of some quick like kinds of things you can do, and then I'll jump into the hands-on side. And you don't have to follow along on the hands-on, because I don't think we have enough GPU nodes for everyone to jump in at the same time. But these are things you can try offline after the class. After the work tutorial is done. So first thing you can do is actually you can find out the kinds of metrics and events you can look at. So, and this, by the way, is probably like 1/10 of the number of options that are there. I just kind of showed you how it pops up. So if you do nvprof with the -- query metrics, it tells you the kinds of things you can measure, basically. So you have instructions for warp, branch efficiency, warp execution efficiency, some kinds of replay options, and sometimes the profiler cannot do both at the same time. Then it will do multiple instances to kind of get the replays to get the info you need. And the same thing with the events. There are the you can also like look at things like active cycles, where basically the processor has an active, in this case the GPU has an active warp, some transactions, and so on. So there's a lot that you can pop out. But to start with, you can do a very simple thing, right? You can just run nvprof on a binary, just like that, like nvprof and the name of the binary, and that will actually tell you that it's starting, and it will connect to the process ID of the whatever process the particular command has. And this was run on an Expanse node, so you can see that it picked up that it's a GPU, Volta GPU with compute cable T7.0, and it's basically doing this output that you see, the performance output, is coming out of the code itself. And then it has the profiling result, and you can see bulk of the activities are on the GPU, like 98%. And a lot of it basically is in copying, like just allocating memory and copying things, and because it's a very simple case, it won't always look like that. But that's the simplest way to get the profile. So for today, what I've done is I've just used the standard CUDA examples. You may have copied these already, but if you haven't, for an earlier case, I don't remember if any of the if Andy used one of these examples or not. But you can copy this directory. All of you should have access to it, and just copy it to the call an examples directory in your home directory. And then to set the profiling up, all you need to do is module load CUDA toolkit and the profiler, and we can compile and run. Now, remember, we obviously can't run on the login node, so you have to get a interactive access to a GP node, like in this case, like for example, you can get for 15 minutes and try these out, but I already logged in to one of them, so I'm going to stop sharing this and share my terminal windows on the second desktop. So can you see my terminals?
Yes.
Okay, and let me turn my video off so that, oops. You can still hear me, right?
Yeah.
Okay, great. So I already did this. If I scroll back here, I already did this from a test account, and I did this from a test account just to make sure that everyone can do it and not me because I have access to some particular directory or something like that. So let's see, we have someone coming in. Okay. So I'm already there. What I'm going to do is a module reset followed by the load. And the reset is because sometimes when you do an srun, you might pick up the CPU environment because that's what was on the login node and it exports it by default. So you do that, it's going to say resetting modules to the system default, and then you should see everything. And there's the toolkit and the profiler loaded. So let's go to this Nsight examples directory, or actually I was in the examples directory. Let's see. And let's do the simple one first, the matrix multiplication directory. So if this is not already compiled, you can just type make and it should compile because the toolkit has the NVCC compiler and the make file already has everything set up. So now we have the binary. And before I do that, let me actually show you the query metrics. So nvprof dash query. I just want to let you know, show you that it's a lot more than what was on that page. So you can see all the kinds of gory details you can actually find, like store transactions, local load transactions. This is on the GPU, and like the device memory stuff, like the L2 and the DRAM, and so on. Like there's a lot of, and then there's single precision flops, like double precision flops, and all kinds of things that are in the list of metrics that you can look at. So it's a huge number of things. So you can see all the warp level instructions and stores and things. And then similarly, if you do a query events, you will see a lot more events also. So the active cycles and all we were looking at, but you can see all the kinds of floating point instructions and on different partitions and so on. So it's a lot that you can look at, and you can choose these at runtime. So, but we are just going to run the nvprof as is with nothing else going on, and you can see it's pretty much went through very quick. Let me admit there, and you can see all the API calls that were involved in this case, right? Now, if you want to do a little bit more tracing, I went to a different example. So let me go to something that has a little more compute, basically. Right. So this is the linear solver example, and we're going to do some tracing on the GPU side. So now it's going to give you a timeline of everything that's happening on the GPU in chronological order. So there's going to be a lot of info here. And this one, maybe I should broaden this a little and see if it becomes readable. But you can see, I'm going to close this out here. So you can see when you run this, it's going to look at every, so all the device info is there, and then all the kernel info that's coming up here. And you can see every little thing. And these are at microsecond scales, right? So you can actually see all the things that are going on in quite a bit of detail. And these are all the functions that are getting called and so on. So you can get like tracing at a very fine detail on the GPU. Now, this is all text-based and on a CLI, so it might get hard to look at, and that's why there's the Nsight tool that will make it easy to look at it graphically. But you have to remember that that also comes with overhead, right? Like, for example, it's easy to run this on a remote machine, but if you have to run it graphical interface, you might end up with having to do XLM forwarding, and then all the associated network delays and so on, make it a little difficult to manage, which is why they have the option of writing out the file and then reading it somewhere else. So that was on the CPU side, but you can also do look at things on the host and see how the API calls were invoked. And again, you can look at the chronological order. So let me do that. So running the same thing with a different option now. Let's go back here. So now we are running with the print API trace. So now you're looking at the host side of things, and you can see all the calls that you have, the API calls, that get attributes for the devices, and then some mem copies and mallocs that are all initiated from there. And you can look at the launch kernel, the kernel being launched, and so on. So there's a lot of info again on the API side. So between these two, you can get a picture of the timeline of what's going on. And if something is majorly delayed, and you'll see that delay in one of these, and that can probably give you a hint of where things are slowing down. Now there is this last part here, which lets you collect info on like selected metrics, and this one you need a root to run, and this is what I'm saying with the restrictions that are there. So here I'm actually looking for particular things. Remember when we did the listing of the metrics and the events, there were all these options. So I picked some of them, and like the number of WAPs launched and the active WAPs and the instructions issued, and then looking at on the metric side the double precision, flop count, and so on. Actually, you should probably change this to single precision because this is a single precision code. But anyway, you won't be able to run this, but I can, and I should probably put this profile online so you can look at it. But this is sitting in my examples and site. I think I have it out here. Let's see. Oh, yeah, in the profile. So when you run this, you'll get an output that looks like this. Let me show you. So again, we're running the same code, but with the different options. And now you can see that for each of the kernels, you can see the WAPs launched, the active WAPs, and the min and the max and the average across the whole period, and so on. Going down to the metric side, you can look at the flop count, and you can see if you go all the way down here, you can see there's a huge number of flops in these functions here, basically. The transpose, non-transposed by level kernel out here. So you can see 640,000 instructions there. So, and this is a single precision floating point. So you can basically look at what's going on in the code at like a summary level very easily. Now there are options to profile specific parts of the code and so on. But it gets a little difficult to manage when everything is text-based like this. Now, one other thing I wanted to show you was the system profiling for an that adds in info on like the power, the clock, and the thermal behavior of the GPU. So that I think I can run normally. So I'm going to try that on there. So you should be able to run this also, I think. So again, so what did we do? We added a flag here. If I scroll back, what I did was add a flag which says system profiling on, and I still do the GPU trace. Now you'll see interspaced with all the other info, there's also the clock and the power limit info and so on. So you can tell if something is throttling, or things are getting too hot, or the clock went down clocked because of some other reason. You'll be able to see things like that. And since you will know it along with all the info of what's going on the GPU, you might be able to figure out, oh, this particular routine is triggering something on the system. And this happens actually. Funnily enough, it happens with the most efficient code sometimes. So we had this happen on Comet with one of our users who had a really efficient GPU code, so much so that it was basically driving it to the limit on the power and on the thermal. So it was downclocking. So he was getting good results for 10 minutes of his run, and then it would just downclock and lose half of the performance, and then it would come back a little later. So that kind of stuff you can notice out here. I mean, these tests are too quick, but you can see the kind of info you can get. So that is that. Now you can also do a dependency analysis, and I'll leave that up for now. And then you can go look at an OpenACC example, and I think I copied. Let's see. So let me copy over this directory, which has the OpenACC code. And this is in the slides, and it's uploaded, so you can try it out yourself later. So now this is just an OpenACC based code, and I can just run. Oops. Sometimes these copy and paste don't quite work. Okay, now it works. So now you can see, again, it's profiling the OpenACC code, and you're getting a similar result of like all the GPU activities and the OpenACC parts of it, and it actually gives you the line numbers and where the time is being spent and so on. So you can take a look at where the computes are going on. So it's pretty nice, just an easy way to profile, and you can also do a trace with OpenACC as well. So if you do that, it's amazing. I don't know why what it's there must be one weird space there. So when you're copying and pasting, just be maybe just autocomplete it so you get the right one. So now you can see this is a trace, and similar to what we saw before, now you have the timeline of all the stuff that's going on, and with the source location on the right. So it's pretty nice. So it's got a lot of info there. You can also export this so that it writes out the profile to a excuse me, a format that can be opened with NVVP. And I think I'm going to stop sharing and go back to the presentation to show that piece. Let's go back to, oops. Oh, yeah. So we are back to the presentation. So basically, we walked through all these pieces in the 2 slides, and you should be able to do all of them except for this metrics piece. Every other thing should be open to all users. So and there are other options, like I said, so you can play around and see how much info you can glean out of this. But one thing you could do instead of just looking at the text is to export the profile and then use it, open it in a visual profiler, and which is what I did. And I'm not going to even try that in a demo because that X11 is going to be really slow. But you can see now you see the same info, but it's in a nice visual form, and you can scroll and look at things. And then you also have the textual output that you had before on the at the bottom. This is the OpenACC details basically. So that's a nice thing that you don't only have to look at it on the text side. You can always go back to the visual option. So that's kind of the simpler option to look at performance, profiling and everything. But there's also the Nsight tools that let you do a much more detailed look at things. So there are two pieces to this. Nsight Systems basically gives you system-wide performance info. So it will combine info from both the CPU and GPU side. So it's a full system view of the code execution, and you can find bottlenecks at all kinds of levels. So like at the GPU levels with the GPU starvation, synchronization issues, memory access, data inefficient, movement inefficiencies, or if there are some CPU level inefficiencies, you can see that. And you can run this both in the command line and graphical mode. When you run it in command line mode, you can also dump out the file to a report file and then download that file and open it on your laptop or your desktop. So, which is what I did in this case, because you can open the GUI from Expanse, but it's going to be really slow. So, and NVIDIA makes the tool available for download if you sign up for their developer account there. And there are lots of tracing options in this. So you can trace cuBLAS, CUDA, cuDNN, OpenACC, OpenMP. OSRT is like the operating system runtime stuff. You have MPI options with OpenMPI and MPage. You can do back traces and a lot of interactive stuff. And if you go to the user guide there, they have screenshots for every one of these things that I've listed there. They have nice info on them. As I said, on Expanse right now, because of security reasons, we have some limitations. But you can still run Nsight Systems and get quite a bit of info. But if you want to use the GUI, I would suggest trying to do it on the desktop, because you might have a really laggy response if you try to do it from Expanse directly from a GPU node, for example. So in this case, this is one of those things where when I started testing, I found a bug with the existing Nsight install, which is a little older. So I stuck a new install in CM shared examples that you can use. But basically, to use it, it's a very similar thing. We do an srun to get a node, do a module reset, load the CUDA toolkit. Don't load the profiler because we're going to use Nsight now, and just change the path. And the tool's nice enough that if you just give it the path to the binary, everything else gets picked up automatically. So you just need to set that path to get the binary. And then we're going to do the same code now, but we're going to do an NSYS profile and say we are trying to look at CUDA events and the operating system runtime stuff. And the -O option basically says output the profiling info to a baseline report file, and then also write out the output to the regular output. So those are the options there. And when you do that, you will see something like this. You'll see NSYS profile. If you run that, again, we're running the same code, so you'll see all the step outputs that we got before. So it's running the code, reading in the matrix, and doing the operations basically, and showing the output. It basically calculates it on the CPU, calculates it on the GPU, tries to basically make a comparison. So you can see speed up between the CPU and GPU. And this is a really small problem, so you'll see that when you look at the profile, most of the time is spent in like CUDA allocations and CUDA free and those sort of things, and the compute is really small. But it's a good quick case to run. And once it does that, it actually saves this to a report file that you can read basically. And what I'm going to do is basically, and in this case, actually, I think I probably copied the wrong one because it was not overriding the existing file. So you have to delete it or rename the file and it should be okay. Or use the force override. So if you look at the profile, it looks something like this. So maybe, okay, I think I'll show this and then go back and run it manually and show you. So you can see all the CPUs, the threads, then you can see the CUDA side of things, all the streams there. And if you open up the info, you'll see where the compute's going on. So you can see there's a lot going on that's more on the OS runtime side and the API side. It's like the whole thing is a setup. And then there's this tiny piece down here on the right, which is basically all the compute on the GPU. But I mean, you can see, and if you zoom in, and the nice thing with the tool is you can zoom in and look at things, and you'll see all the kernels, and then you'll see there are basically all the functions that were there before. And you can go back and match this with the nvprof and see if we picked up the same kind of function. But now the nice thing is you can actually look at it on the you can zoom in and look at particular functions, and if you actually hover over it, it's going to give you more info, and which is what I'm going to show you now. So let me exit out of this and open Nsight on my so I'm going to stop sharing that one and open Nsight, which should be already open. Yep. So I'm going to look at the baseline. So this is basically the profile that I generated on Expanse, downloaded it onto my laptop and opened it with Nsight Systems on my laptop. And now I can actually look at things in detail. So, if I hover over this, you can see what the function is, basically the grid and block, and how much memory is involved, and so on. So it's actually a lot of details on each of these things, right? And you can see there's a different function here, and again looking at everything in detail again.
Sorry to interrupt. Could you share this thing with us?
Oh, sorry. Yeah, let me do that again. Thanks for letting me know. I'm talking to myself then. Okay, do you see it now?
Yeah.
Yes. Yes.
Okay, great. Yeah. So yeah, so this is basically, I downloaded it to my laptop and opened it up in Nsight Systems on the laptop, and then I just zoomed in. So maybe I should actually zoom out completely and then go to reset zoom. This is how it looks basically. So so you can zoom into particular pieces if you want, and right click and zoom into selections, and you can actually see the kinds of instructions that are involved. So there's a instrumentation setup and all that, right? And you can scroll across, and there's a timeline on the top you can see. So there's a lot of CUDA's free and setup stuff, but this is where the bulk of the action is, and you can see. Yeah, and I should be able to hover on top of this. Oops. Let me see. Oh, I should probably choose one of these. So you can also see when I right click, it has the analyze the selected kernel with Nsight Compute. So it'll actually give you the uh, uh, the command line to use basically uh, uh, to do the analysis of this particular thing on using the Nsight Compute, which will actually let you drill down to a very deep level. But what I was trying to show you was actually it's supposed to show. I think I might have lost mine. Okay. So you can actually get more info on each of these functions. Oh yeah, there you go. So when you hover over it, you'll see more detailed info on the function that's there in that piece of code that's running basically in that timeline. So what this lets you do actually is uh, um, easily figure out, like, if your GPU is sitting idle for a long time, or why it might be sitting idle. Like you can kind of drill down into it, and like you see here, you can use that info to go run an Nsight Compute piece, which unfortunately we can't do right now. But if you in an optimization cycle, that's what you would do. You would run that and then get even more detailed info on that piece of code. You can actually instrument it even more. So if you feel like, hey, this is taking too long in a particular piece, uh, uh, so this code is probably like the wrong thing to show, because basically there's a setup and the code itself is short. But if you're running a real production long running code, this initial piece is not going to be the dominant piece. There'll be lots of compute and waiting in between and so on. So you can look at all those things. So let me go back to the presentation. I'm going to keep that open because there's some more info that I want to show you on a different plot. So let me do that. Okay, so we're back here. So one of the things you can do
Mahi,
is
we're seeing your not presentation mode, but the presenter screen.
Okay, let me just swap it. Better?
That's much clearer. Thank you.
Okay. So one example to illustrate this is basically there's a sample code, and I just got it off the NVIDIA profiler example. But basically this code uses unified memory, and it does some vector addition. And in the code, there is an option to either prefetch the data or not. And what you can do is run it with and without and see what you get, basically. And we can look at the profiles. So let's do that. So I actually ran that already. And if you want to look at the commands, that particular link has the command and the code also, so you can actually download and run it. But let me go back to sharing the Nsight piece. Best to do the desktop so that you can see all of it. So you can see my profiles again, right?
Yes.
Okay, great. So let's start with the no prefetch thing. And this is again zoomed in already. So let me get out of this first. You can see there's a lot of CUDA malloking and stuff going on in the beginning, but the actual kernel, which is out here, is a small piece here. So I'm going to zoom in there to show something interesting. So let me zoom in there. And in this example, what happens is what you'll see is the kernel is taking a lot longer than you expect. And when you look into it, what you can see is while the kernel is doing the addition, there's also all this host to device and device to host transfer stuff going on. So, and I'll show you the code after we are done looking at this, and you can kind of guess what's happened. But basically, you can see there is a lot of memory transfer activity going on along with the kernel actually executing the addition, because you used a unified memory and you didn't prefetch. So it's going to try to move data when it's requiring it, and that's going to be slower, obviously, because of the way things are not bundled together, and it's blocking on the memory transfers, right? So that's like one view of it, right? Now, what you can do is go back and say that, oh, I'm going to just change it to prefetch. And you can already see it's a lot cleaner, but let me just reset. Now, again, there's the setup piece, but if you look at the place where the kernel actually runs, zoom into selection. So now you see that there's no compute going on when there's the prefetching going on. So you can actually see the prefetch piece there, right? Like, and you can see the high throughput there, 12 gigabytes per second. And pretty much, I forget, I can look at the code after this, but basically it does a huge amount of memory allocation. So, and then moves it to the device, and that's what the prefetch is doing. And this is the compute piece. So let me, oops. So now you can see the addition is just happening clean without any blocking due to memory or anything like that. So obviously it's going to be a lot more efficient. So that's a quick example to show you like the kinds of changes you can make, and you know, the optimization process is also similar. Like you might notice something, and when we did the GPU hackathon, we were doing this with a lot of the codes where we would say, oh, like there's a huge weight here because, you know, data is being copied in, and then you go look at the code and say, oh, that's because, you know, the code is doing XYZ here. So we should look at the code now and see if it makes sense. So let me share the screen, the desktop with the code. So I think I have it here. So yeah, this is the add CUDA code. And let me, is that visible, the code? Maybe I'll make it bigger.
Looks good.
It's readable, right? Okay. So you can look at the kernel and the code. It's pretty simple. There's the vector addition piece, and that's out here, and you can see initially there is a unified memory accessible from CPU or GPU, that CUDA malloc managed piece that's being allocated here. And if you look at it, basically you have, I'm trying to go back here to see where that managed piece is. I have to go way back. You can see the CUDA malloc managed there. And basically that's the piece that's coming up from here. So that's where you're allocating the unified memory that's accessible from both CPU or GPU. Now the danger with that is what is happening if you don't prefetch, right? It's because it's now going to piecemeal that movement and then end up with a blocking situation. So now then we just initialize it on the host, and there is this block here where if you set the prefetch to off, or if the prefetch is null, sorry, if its prefetch is not set to off, or if it's not set at all, it's going to just do the prefetch, and it'll get the device and it'll do the prefetch of that array, of those two arrays, so that it's ready for the code while it's when it's doing the actual addition block here. So it's basically 1 million elements and it does the addition here. And then it does a synchronize, which piece we didn't look at, but basically that's what it is. And then it just writes out and does a CUDA free at the end. And you'll probably see the CUDA free also at the end if you scroll all the way back here. Let's see. I went too far, I think. Should just reset it. Yeah, you can see it here. So there's all the
something has frozen. All I see is your terminal screen.
Oh yeah, because I'm on the because I'm off the okay. I'm going to go back to that, but I'll go back to the profile. But basically, so you see the code now, right? Basically, you're doing a memory allocation, unified memory allocation. You have the option to run prefetch or not, and then you do the addition and then synchronization. So what I'll do is stop that back and then go back here and share this screen again, the Nsight. That's what I was trying to do. You should see it now, right?
That's what I thought. Yeah, we see the Nsight now.
So now you can actually see the tail end of everything there, which is the zooming in into there's all the info that's being copied back, basically. So, and that was the original managed piece. And then the add CUDA, this is the actual CPU process. And you can undo the CPU process and see that this particular one just used one task, and you know which CPU it was on, and CPU 12 basically. So, and if you had a MPI, then you would have an MPI tab for each MPI task. You would have things. So it's actually very nice to kind of have everything in one place and start looking for bottlenecks. So that's the neat part of. So you can see now on the CPU side what was going on and so on. So there's everything in one place. That's what I would say. And then this is an event view, but if you can do a bottom-up view, top-down view, you can actually look at. Let me see if I can do that here. So you can actually see the processes, and there's a filter. I need to unset the filter. But if you unset the filter, you'll see all the pieces of the code. So that's the Nsight Systems piece. So the way the workflow goes is, let me go back to my presentation, which is not visible anymore. Let's see. Do you see my second desktop with the presentation, or?
No, we see the Nsight tool. Now I see your presentation from the presenter's viewpoint.
So I can do the swap again. This is so complicated.
There we go.
Okay,
that looks good.
Great. So yeah, just having two desktops is nice for kind of showing multiple things, but all these windows are all over the place. So we looked at the sample code, and if you go to that website, they kind of explain in a lot more detail. But essentially, what it lets you do is look into the all kinds of levels of detail on what's happening with the memory transfers, what's happening with the code, is one of them blocking something else, those sort of things. And then we did the prefetch and see how it cleaned up. So the last piece I want to look at is Nsight Compute, and actually in this case I don't have an example as such except for output that I got by running as root, which I can just show you, but hopefully we can get this opened up in the next few weeks so that you can still try these pieces out. If that happens, I might do a little like a small small talk or just have slides uploaded with more details on Nsight Compute. But basically, this is just a kernel profiler for the CUDA application. So remember in the previous systems, Nsight Systems output, when I right-clicked on one of those functions, it said, do you want to profile this with Nsight Compute? You can do that actually. And then with the command that it spit out, so you can go run that command and get now like really detailed profile of that kernel that you were looking at. And this is part of, again, the CUDA toolkit, and you can also, as a developer, download it on your for your laptop. But basically, it has both a GUI and a command line option. Now here you can look at, again, a lot of things actually. You can compare performance metrics between like a baseline run and a run that you're doing now. So like you're changing things, then you can actually see very easily, oh, what changed like when I did this. So like the kinds of things we are doing with systems, where like looking at the two plots, you could do that a lot easier in Nsight Compute. You can do a task graph profiling, and it can also correlate back to the source much better, so you can actually look at which part of the code is doing stuff. There's a roofline analysis to kind of tell you how good you're doing, like what's your actual limit that you can achieve and how you're doing relative to that. And there's a nice blog post in NVIDIA basically where they go through like an optimization procedure. It's a 3-part post, so it's a lot of detail, so you can look at that. But that's another nice tool basically. So let me show you one of the outputs I got, and I think that should be on my. So this is something that I ran.
Did you want to share that desktop?
Oh yeah, thanks for reminding me again. Let me get that. Okay, yeah, here you go. So you can see it now, right? Let me close this so that I can give you a little bit more. Okay, so there's the old sudo command. So I had to do a sudo Nsight Compute, what basically the CLI option, and then I ran this test case. And this was the case that's in that blog post, so you can again correlate back to that. But basically it does multiple passes to kind of get detailed info on the kernel. And then again, you now see all kinds of info on the frequency, the memory, the cache stuff, and then the info on the warps and the active warps and so on. And again, this was again a quick thing that I did. If I had the CLI, I mean, a GUI based approach, then I could have done all the nice roofline and those sort of things. I just wanted to show you this piece, even though right now you can't use it, but you can look at that post to kind of get a sense of the kinds of things you can do. But if we get it enabled, I'll let you know, and we can send a email out saying it works. Eventually what we are thinking of doing is, so I should explain, like, I think part of the security issue is that if there are multiple users on the same device, on the same node, and these options to profile are turned on, there's a possibility that you can look into other people's code and so on. So that's so the way we are thinking of getting around it, and we have to test this, is to make it an exclusive node and see how, at what level we can open up. So that's something we're testing now, and if it works, we'll let you know. So those are the that's a quick introduction, and let me go back to the slides. Let's see the PowerPoint. Okay, you see my main slide or the?
Yes.
Okay, great. So just to summarize what we looked at today. So basically, there are lots of command line and GUI options. Right now, some of these features are limited by permissions restrictions, and we can hopefully enable some of these. nvprof is kind of the simplest tool, and I would say that's the one you should try out if you're trying a lot of things. It's got a command line approach, and you can run most of the options except for the detailed metrics piece. Again, needs the root level access, but and the CUDA and OpenACC codes can also be profiled. I mean, basically all types of codes that use GPUs can be profiled. I think you can. There are examples with Python, like you can use this to profile TensorFlow runs and so on. Similar thing with Nsight Systems, you should be able to do those. So Nsight Systems gives you both the CLI and GUI option, and you can do system level profiling. So you're looked at how you can look at both the CPU and the GPU components at the same time, and like drill deep into, okay, which piece of it is blocking, or why it might be happening, and then you can go back and correlate with the code, make the change, come back and see if the profile changed. So that's a good way of figuring out if you're doing something useful or you need to take a different direction. And the Nsight Compute is it drills down even more into the kernel profile for the CUDA applications. Again, it's disabled right now, but we'll let you know if it opens up. So I think I'll stop at this point and take some questions. And if people want to try out, you can try out the examples. Let me pop up the chat. I only see one thing. I assume this was when I was off showing a different terminal. So I can take some questions now.
Yeah, so also remember before you head out of here that you're registered for both sessions. So those of you who go off, we'll see you in 2 weeks. In the meantime, some questions. I have a quick question, Mahi.
Yeah.
So the two really, the nvprof and gprof. nvprof is for GPU and gprof is more for CPU, but they're very similar, right? And would nvprof capture MPI calls?
I think you can. I'll have to go back and check if there's an MPI. I know the Nsight Systems has an MPI option.
Okay.
Yeah.
Yeah, I saw that on the chart that you showed.
Yeah. So it should. I think it should be fine. It'll probably create different profiles.
Here's a question from Caroline. You want to answer that?
Oh, just pure MPI profiling. So right now we have MPI-P, which is probably the lightest weight one that you can have. But I'm going to probably get Tau installed very soon. That'll give you a lot more detail. And eventually, I think the HPC toolkit also should work on the AMD side. I haven't had a chance to try it out yet. But at present, the best option, easiest option is MPI-P. And I think there is an example in the CM shared examples. Let me double check.
Yeah, I think we included it in a talk in the last week or two. What's the timeline for Tau? It would be great to get a short overview for the class if it's available by the
Oh yeah, we should be able to do it in that time.
Because we have a couple sessions that aren't quite scheduled out yet. So would anybody raise of hands if do you know what Tau is? Maybe Mahidar can take a second to
So
explain.
Tau can basically do profiling and tracing at a very fine-grained level. And what you are seeing with the Nsight Systems at the GPU and CPU combined, Tau is basically, I think Tau also looks at all kinds of things. So a lot of details.
There you go. I'll put the link in the chat.
So I'm actually trying to look at the MPI-P. Looks like I don't have an example in the CM shared
for the
examples.
MPI-P?
Yeah. But we did talk about it in one of the classes,
Yeah.
right?
I believe
So,
it was week
Caroline,
6.
I can actually, I'll actually get it.
Here we go. Yeah, I talked about it and I included an example in week 6 in the repo.
Okay.
And I took it from your stuff, Mahi. So it's yeah, you and I were working on it together.
Correct.
That one day.
Yeah.
Okay. So yeah, just look in the week 6 repo under examples and you'll find it. MPIP are calls that you make from within the code.
Yeah.
So it's a whole API for MPI. So it's internal to your code, but it's very helpful.
So with these profiling tools, yeah, there's always two ends to this, like the things like nvprof or gprof or like even like MPIP give you summary information and kind of let you spot things that are obviously wrong or like some bottlenecks that are very obvious. Then on the other end, you have things like tau and the Nsight Compute, which can go very deep into every piece of the thing, but that's a lot of info and it takes a little bit of like a learning curve to kind of get used to using all that information and actually figuring things out, because it can be a little bit overwhelming to have so much info. But yeah, I think we can definitely run through like an example. And actually the tau people have I mean, the group has a really nice tutorial that kind of goes into the kinds of things that can be done.
Yeah, I think it would be a good module to add to the training, just to show. It's nice to see an idea of what you could want to look at.
Yeah.
Mahi went through a lot today and gave you 3 tools, but by seeing them and how Mahi uses them, you get the idea of, oh, down the road when I work on real code, I may need to want to use this kind of tool so I can dig into my bottlenecks when you get to optimization. And like tau, it does take some training practice. Any other questions? Okay, well, maybe I'll stop recording. Thank you, Mahi, for your excellent presentation.
Thanks.
Now you guys know how to do CPU and GPU profiling. Thank you.
And like I said, if